When installing multiple branch circuits in a single conduit, it is permissible to use a shared neutral and ground wire, given certain conditions are met. Firstly, each circuit must have its own dedicated circuit breaker or fuse. This ensures that an overload or fault on one circuit will not impact the others, maintaining the integrity and safety of each individual circuit. Secondly, the conduit selected must be adequately sized to accommodate all conductors, including the shared neutral and ground wires. Overcrowding a conduit can lead to overheating and potential insulation damage, posing a significant safety hazard. Thirdly, the conductors used for the circuits must be of the same size. This ensures that each conductor has the same current carrying capacity, preventing any imbalance or overloading of individual conductors. Fourthly, the neutral conductors from both runs must be properly terminated at a neutral busbar or terminal block within the conduit. This provides a common point for the neutral current to return to the source, ensuring a stable and balanced electrical system. Fifthly, the ground conductors from both runs must be properly terminated at a grounding busbar or terminal block within the conduit. This provides a path for fault current to return to the source, tripping the circuit breaker or fuse and preventing electrical shock. There are advantages to using a common neutral in such scenarios. Firstly, a reduced number of wires are needed. Using a common neutral reduces the number of wires running through the conduit, making it easier to pull and terminate the conductors. Secondly, there are cost savings associated with this. Using a single neutral wire instead of multiple neutral wires can result in savings on material costs. Thirdly, the wiring process is made easier. Connecting the neutral conductors to a common busbar or terminal block simplifies the wiring process. Remember to always follow all applicable electrical codes and regulations when installing multiple branch circuits in a single conduit. These codes are designed to ensure the safety and reliability of electrical systems. When calculating the allowable ampacity of conductors in a conduit, it is important to consider the number of current-carrying conductors and apply the appropriate dirting factors. This ensures that the conductors are not overloaded and that they operate within their safe temperature limits. For example, National Electrical Code, or NEC Section 310.15. B3. Provides adjustment factors for more than 3 current-carrying conductors in a raceway or cable. These adjustment factors reduce the allowable ampacity of the conductors to prevent overheating. When determining the required size of a conduit, it is important to consider the fill percentage allowed by the NEC. The fill percentage is the percentage of the conduit's cross-sectional area that is occupied by the conductors. NEC Chapter 9, Table 1 provides the maximum allowable fill percentages for different types of conduits. It is also essential to ensure that all electrical connections are made properly and are tightened to the correct torque specifications. Loose connections can cause arcing and overheating, which can lead to fires. Use a torque wrench to tighten connections to the manufacturer's specified torque. Grounding is a critical aspect of electrical safety. A properly grounded electrical system provides a path for fault current to return to the source, tripping the circuit breaker or fuse and preventing electrical shock. The grounding electrode system must be installed in accordance with NEC Article 250. This includes the use of a grounding electrode conductor to connect the grounding electrode to the service equipment. When working with electrical systems, always use appropriate personal protective equipment, or PPE, such as safety glasses, gloves, and insulated tools. This will help to protect you from electrical shock and other hazards. Before working on any electrical circuit, always de-energize the circuit and verify that it is de-energized using a voltage tester. This will help to prevent accidental electrical shock. Never work on live electrical circuits unless you are specifically trained and authorized to do so. Even then, it is always best to de-energize the circuit whenever possible. Be aware of the potential hazards associated with electricity and take the necessary precautions to protect yourself and others. Electricity can be dangerous, but it can be used safely if you follow the proper procedures and use the appropriate equipment. Always consult with a qualified electrician if you have any questions or concerns about electrical work. A qualified electrician has the knowledge and experience to perform electrical work safely and in accordance with the electrical code. Consider the neutral load. A neutral conductor only carries the unbalanced current from the other conductors. In a balanced three-phase system, the neutral conductor carries very little current or no current. In a single-phase system, the neutral conductor will carry as much current as the ungrounded conductor. Consider the voltage drop. All conductors have resistance, and the longer the conductor, the greater the resistance. The greater the resistance, the greater the voltage drop. The voltage drop can be calculated using Ohm's law, which states that voltage is equal to current times resistance. If the voltage drop is too high, it can cause equipment to malfunction or not operate at all. The NEC recommends that the voltage drop on a branch circuit should not exceed 3%. Consider the ambient temperature. The ambient temperature is the temperature of the air surrounding the conductors. The higher the ambient temperature, the lower the ampacity of the conductors. This is because the conductors will generate more heat at higher temperatures, and this heat needs to be dissipated. The NEC provides ampacity correction factors for different ambient temperatures. Consider the type of insulation. The type of insulation on a conductor affects its ampacity. Some types of insulation are better at dissipating heat than others. The NEC provides ampacity ratings for different types of insulation. Consider the location of the conductors. The location of the conductors can also affect their ampacity. Conductors that are installed in a confined space will have a lower ampacity than conductors that are installed in free air. This is because the confined space will trap heat, which will cause the conductors to overheat. The NEC provides ampacity correction factors for different locations. When sizing a conduit, it is important to consider the size and number of conductors that will be installed in the conduit. The NEC provides tables that list the maximum number of conductors that can be installed in a conduit of a given size. These tables take into account the size of the conductors, the type of insulation, and the fill percentage of the conduit. The fill percentage is the percentage of the conduit's cross-sectional area that is occupied by the conductors. The NEC limits the fill percentage to prevent overheating of the conductors. When pulling conductors into a conduit, it is important to use a lubricant to reduce friction. This will make it easier to pull the conductors and will prevent damage to the insulation. There are many different types of lubricants available, so it is important to choose one that is compatible with the type of insulation on the conductors. It is also important to avoid over-lubricating the conductors, as this can make them slippery and difficult to handle. When terminating conductors, it is important to use the correct type of connector. There are many different types of connectors available, so it is important to choose one that is compatible with the type of conductor and the type of equipment to which it will be connected. It is also important to torque the connectors to the manufacturer's specifications. Over-tightening the connectors can damage the conductors or the equipment, while under-tightening the connectors can cause a loose connection, which can lead to overheating and fires. When installing ground wires, it is important to use the correct size of wire. The size of the ground wire must be large enough to carry the fault current. The NEC provides tables that list the minimum size of ground wires for different sizes of circuits. It is also important to connect the ground wire to a grounding electrode. The grounding electrode provides a path for fault current to return to the source, which will trip the circuit breaker or fuse and prevent electrical shock. There are many different types of grounding electrodes available, so it is important to choose one that is appropriate for the soil conditions at the site. It's vital to consult the latest edition of the NEC and local electrical codes for specific requirements and regulations. These codes may vary depending on the jurisdiction and the type of electrical installation. Staying up to date with code changes ensures that your work is compliant and safe. The NEC is updated every 3 years, so it's important to have the latest edition. Familiarize yourself with the relevant articles and sections of the NEC that pertain to branch circuits, conduit installations, and grounding requirements. Pay close attention to any local amendments or interpretations of the code. These may be specific to your area and can impact the way you perform electrical work. Obtain the necessary permits and inspections for your electrical work. Permits are required for most electrical installations and provide an opportunity for a qualified inspector to review your plans and ensure that your work meets code requirements. Inspections are conducted after the work is completed to verify that it has been done correctly and safely. A properly installed and inspected electrical system is essential for protecting people and property from electrical hazards. Working without permits or inspections can result in fines, penalties, and potential safety risks. Maintain accurate records of your electrical work. This includes detailed drawings, specifications, and test results. These records can be helpful for troubleshooting problems in the future and for documenting compliance with code requirements. Keep your records organized and easily accessible. This will make it easier to find the information you need when you need it. Consider using a digital record-keeping system to store and manage your electrical documentation. Digital records are easier to search and retrieve than paper records. Regularly inspect your electrical system for signs of damage or deterioration. This includes checking for loose connections, frayed wires, and damaged equipment. Repair any problems promptly to prevent them from escalating into more serious hazards. A regular inspection schedule can help you identify and address potential problems before they cause a fire or electrical shock. Consider using a thermal imaging camera to detect hot spots in your electrical system. Hot spots are often an indication of loose connections or overloaded circuits.